Have you ever wondered how it would be if we could manipulate matter on an atomic level? Welcome to the fascinating world of nanotechnology, an area of science that is changing the way we understand and interact with the world around us. Nanotechnology operates at a scale so minuscule that it's beyond our normal comprehension. We're talking about the nanoscale between 1 and 100 nanometers. To put that into perspective, a nanometer is 1/1000th of a meter. That's the scale at which we can start to manipulate individual atoms and molecules. This technology is not just a scientific curiosity. It has the potential to revolutionize fields as diverse as medicine, electronics, and materials science, opening up a world of possibilities that were once the stuff of science fiction. Just think about it for a moment. Imagine the infinite possibilities that this technology can bring in our world. So how does this fascinating world of nanotechnology actually work? Well, picture yourself playing with Lego blocks. You're piecing together individual blocks to construct a grand castle or a soaring spaceship. Nanotechnology operates on a similar premise, but with a key difference. The blocks you're working with are individual atoms and molecules, and your creations are on an incredibly minuscule scale, the nanoscale, to be precise. When we talk about the nanoscale, we're delving into dimensions that are almost unimaginably small. Imagine a single sheet of paper. Now, imagine slicing that sheet into 100,000 equal parts. The thickness of one of these slices is approximately 1 nanometer. That's the realm where nanotechnology comes into play. At this scale, the fundamental properties of matter can change. Materials can become stronger, lighter, or more reactive. They can conduct electricity or become magnetic. It's like entering a new world where the rules of the game are different. Now let's try to comprehend how nanotechnology works. It involves manipulating these individual atoms and molecules to create nanoscale materials and devices. It's akin to being an architect, but instead of using bricks and mortar, you're using atoms and molecules to create new structures. This can be done through top-down methods, where larger materials are broken down into smaller ones, or bottom-up methods, where atoms and molecules are assembled into larger structures. The science behind nanotechnology is a fascinating blend of physics, chemistry, biology, and engineering. It's about understanding the unique behaviors of atoms and molecules at the nanoscale, and then using that knowledge to create novel materials and devices with unprecedented properties. Nanotechnology is like the ultimate form of Lego play, where you're not just building structures, but you're also creating new materials with tailor-made properties. It's about controlling and using matter at the smallest scale to create something that has a big impact. So, the science of nanotechnology is essentially about controlling and using matter on a tiny scale to achieve something big. Now that we understand the science behind nanotechnology, let's dive into the world of nanomaterials. Nanomaterials, as the name suggests, are materials that have been engineered at the nanoscale, which is incredibly small. Think 1/1000th of a meter. This might sound like science fiction, but it's a reality that's changing the world around us. Creating these materials isn't about shrinking down existing things, but rather manipulating matter at the atomic and molecular levels. This is the realm where quantum physics reigns supreme, where materials behave in ways that can seem truly magical. Because of their minuscule size, nanomaterials have properties that are distinctively different from their bulk counterparts. For instance, their increased surface area relative to volume gives them an enhanced ability to interact with their environment. This results in greater chemical reactivity, which can be harnessed in a wide range of applications. But the magic doesn't stop there. Nanomaterials also exhibit increased strength and lighter weight compared to their larger-scale versions. Imagine a material as strong as steel, but with the weight of a feather. Sounds impossible, right? But that's the power of nanotechnology. Another fascinating aspect of nanomaterials is how their properties can change with size. A material might be a good conductor of electricity at one size, but a poor conductor at a different size. This size-dependent behavior opens up a world of possibilities for customizing materials to fit specific needs. So, nanomaterials aren't just smaller versions of what we're used to. They're a whole new class of materials with unique and superior properties. These materials are already revolutionizing fields like medicine, electronics, and materials science, and we're only scratching the surface of their potential. In the world of nanomaterials, small really is mighty. And as we continue to explore and understand this microscopic world, we can look forward to a future full of possibilities that stretch the limits of our imagination. Nanomaterials, therefore, are not just smaller versions of materials. They are a new class of materials with unique and superior properties. As we delve deeper into the world of nanotechnology, we begin to realize its potential and impact. This fascinating field of science is already making significant strides in various sectors, and the implications are staggering. Take medicine, for instance. The application of nanotechnology in healthcare has opened new frontiers, enabling targeted drug delivery, advanced diagnostics, and regenerative medicine. Nanobots, microscopic robots that could travel through our bloodstream, have the potential to revolutionize treatments, fighting diseases at a cellular level and repairing tissues from within. When we look at the realm of electronics, nanotechnology is reshaping the landscape. The miniaturization of electronic components driven by nanotech is leading to devices that are not only smaller but also more powerful and energy efficient. It's paving the way for the next generation of computing and communication technologies. In the field of materials science, nanotechnology is helping us create materials with extraordinary properties. Imagine self-healing materials that can repair themselves when damaged, or metamaterials with properties not found in nature, like negative refractive index, which could lead to the development of invisibility cloaks. And this is just the beginning. The potential future applications of nanotechnology are vast and varied. We're talking about harnessing solar energy more efficiently, cleaning up environmental pollution on a molecular level, and even building elevators to space using carbon nanotubes. As we push the boundaries of our understanding and capabilities, we're starting to realize that the possibilities are limited only by our imagination. The future of nanotechnology promises a world where we can manipulate matter at the nanoscale to create solutions for some of our biggest challenges. But it's not just about the technology. It's about the potential to transform societies, economies, and lives. It's about the promise of a better, brighter future. With nanotechnology, we are not just witnessing a scientific revolution, we are part of it. As we wind up our journey in the nano world, let's summarize what we've discovered. Nanotechnology, the science of the minuscule, gives birth to nanomaterials, impacting and revolutionizing fields like medicine and electronics. So the next time you hear about nanotechnology, remember, it's a small world, but it's making a big difference.